Muito boa tarde, senhoras e senhores. Sejam bem-vindos a mais uma live do Farol de Pouso. Esta que é uma live oferecida pela nossa cara parceira Realizar Escola de Aviação Civil no município de Torres. E hoje nós estamos aqui para um bate-papo super bacana com duas feras. Nós temos aqui o comandante Thiago Brenner, conhecido pelo seu trabalho com o livro de performance, né? Um livro sensacional aí, quem não conhece tem que conferir. É muito interessante, a gente já teve grupo de estudo. O pessoal não consegue ver mas o Conrado tá.
Agora veio, pô, agora veio.
O Conrado tá mostrando aí o canal, o livro. Deixa eu mudar aqui pra cena do bate-papo aqui. Mostra aí, Conrado. Olha aí,
Agora
ó.
sim, ó, agora sim.
Aham. É a Bíblia da performance, né? Muito bom esse material. A gente tinha um grupo de estudos
Sem dúvida.
antigamente aí que a gente usava esse livro como apoio e é muito interessante. E a gente vai fazer um bate-papo em inglês, vai ser um pouquinho diferente, então também é uma oportunidade para você aí que está estudando para o ICAO aproveitar e praticar o seu ICAO aí, né? Então, bastante oportunidades interessantes acontecendo hoje. Então, sem maiores delongas, eu acredito que nós já estamos no horário que a gente tinha estipulado, 2 minutos ainda. A gente pode começar já o nosso bate-papo, né? 2 minutinhos aí adiantado, começando o pushback. E os meninos se apresentam. Eu não apresentei o Conrado. O Conrado é o nosso co-host no podcast, em vários episódios do podcast, a grande maioria hoje em dia. E voa também Boeing 737, né? Os dois comandantes voam Boeing 737 na vida, né, profissional deles aí. O Conrado no mercado do Oriente Médio e o Thiago no mercado brasileiro, né?
Tudo bem.
É isso aí. Então, vou passar o bastão para eles e, enfim, aproveitem, divirtam-se, extraiam o máximo de conhecimento que vocês puderem dessas feras. Com vocês.
Boa. Bom, pessoal, é legal. Muito bem-vindos. Welcome on board. Uma introduçãozinha aqui em português, daí a gente troca o switch para o inglês, reforçando o apoio da Realizar que está com a gente, agradecendo o Brenner aí pela conversa. Essa ideia dessa live surgiu de várias conversas que a gente tem tido e surgiu especialmente de eu falar para o Brenner que eu utilizo o canal dele, o canal Aircraft Performance, como ferramenta de instrução para os meus alunos, né, aqui no 1737. E vira e mexe eu mostro para os meus alunos o material do Brenner ali, os vídeos. E eu tenho que fazer tradução simultânea, né? Porque é em português. E ele usa muita figura, muito gráfico, muita explicação visual, audiovisual, que é muito legal. E eu faço as traduções simultâneas. E a gente começou a falar, pô, quem sabe, vamos começar a fazer um negócio em inglês, né, Brenner? Não é isso aí?
Vamos virar a chave então. Agora vamos ver o que sai aí se eu desenferrujo o inglês.
All right, so it's now 2 p.m. Brazil time, right? So from now on, we start our live in English with Captain Thiago Brenner from Aircraft Performance web channel, YouTube channel. Who hasn't yet checked, you have to do it because it's an amazing tool to learn a little bit about performance. And today, we're going to talk about, the importance of performance. Brenner has published a amazing, it's a Bible, right? It's the Bible of performance. An amazing book that we later are going to talk about, and it's going to be available for you. Either getting in contact with Thiago or getting in contact with us from Farol de Pouso. So, today it's just a little talk about performance and like an overview discussion about why performance is so important for pilots. So, and that could be my first question to you, Brenner. Why do you think performance is so important?
Well, first of all, thanks a lot for the invitation for this conversation, this chat, this informal chat about aircraft performance. It's been a passion of mine to study this subject for a long time now. And I normally tell the same story to everyone who asks about how it all started to me, And it all started when I was flying a single engine, piston engine, taking my IFR lessons. I was about to take off from Curitiba. It's a 3,000 feet airport, elevation airport. And I was about to departure from this airport at full tank on a hot day with full packs, way above the envelope of the airport. And for me, it was never a problem because I normally take off and land from airports close to the ground. Close to the sea level. And it has always been easy to depart from any runway I have ever departed with that particular airplane. But that day, I almost did not leave the ground. Lucky, the runway ended on a valley, so I could depart downwards instead of upwards. Gain some speed.
That happened to me as well.
I promised myself I would never count on luck ever again. I would study performance of an airplane, is either a small airplane, either a big airplane like nowadays. I have the opportunity to fly, but it would be something that was not on luck. I was not counting on luck. I was about to do it the best way I can.
Yeah. Well, that's a good reason. Because I experienced the same in my young ages, flying at the flying school, and one of those cross countries. I think we had an aviation event in Canela, and so we went there with quite a few airplanes from the flying school. And during the departure, I think we were a little bit heavier than we should be. And during the departure, it was like, well, that's not going to happen, And at that time, especially with small aircrafts and with not much knowledge, there is no V1, right? So you just go and pray, That's basically what happened to me. Probably the same as what happened to you, We just go, close our eyes, and say, yeah, it's going to work. It has to work, right? Otherwise, yeah. Well, nowadays, of course, for both of us, flying for, big airlines and flying jets, flying Boeings, it's a bit different, right? So we have a lot of rules to follow, a lot of calculation to do for every performance, for every takeoff, right? And basically, what we do today is taking in consideration our performance factors for each departure, to put all the knowledge together and all the tools we have available to enhance the performance in terms of safety first, right? And in terms of how much of payload available you have, right, to help the company to take some extra cargo and make some profit, right?
Yeah, and
so we could talk about, yeah.
No, it's just that despite having the numbers all set for you nowadays on these computers, like OPT, for example, in case of Boeing airliners, yet most of people don't really understand what those numbers are, or where they come from, or how they are calculated, or what do I have to do to have this number achieved. So this kind of thing made me motivated to study performance even more, especially on FAR 25 part airplanes. That is the Boeing 737 and E2 jets, E1 or Airbus A310D and so on.
Yeah, it's interesting what you mentioned, because the OPT from Boeing, it's an amazing tool, right? It incorporates all those big manuals that we used to have on board, right? And so many numbers and so many stuff that we had to look at and use in order to calculate the speeds, at least, And now the OPT incorporates all that stuff, and it's such a user-friendly tool, but there is a threat on it, and I see that happening quite often. I don't know if you see there in Brazil, because you choose whatever you want, basically, right? You choose either optimum flap setting, or you select one flap setting. You choose optimum thrust rating, right? Or you choose the thrust rating you want, right? And after you run the performance, after you run the numbers, you still have another option. You go full thrust or you go ATM, right? What I notice is that most of the times, because it's so easy to change the settings. It's so easy to just click and say, okay, now I want to go full thrust. I don't know why. I just want to go full thrust, and then they go full thrust, and then they, for some reason, they choose full thrust, and they don't really understand, what is behind it, what exactly they are doing with that, right? I think I don't know if you see that quite often there in Brazil.
More than you think. Let me give you an example. Our company's SOP says that you should choose the lowest flap setting for takeoff every time. The reason behind this is just fuel savings. With a lower flap setting, you have a fuel saving. But they want just a little bit of either ATM or derate just to save the engine a little bit as well. All right. When departing from a relative short runway, say 2,100 meters, 2,100, some people sometimes feel uncomfortable departing on this kind of runway with flap setting 1. This is the lowest flap setting for the 737 takeoff. Then they say, all right, I'm going to change it to 5 because I don't feel comfortable using flaps 1, getting too close to the end of the runway during takeoff. And that's it. That's my choice. All right, we respect that. But try to learn what's behind your decision. Because, for example, if you choose flaps 1, random numbers here. If you choose flaps 1, you will use an ATM of 35 degrees Celsius. And that will put your V1 in a given point of the runway. And if you reject at that point, you end up in the end of the runway, just a few centimeters from the end of the physical runway itself. If you choose flaps 5, you think you are departing sooner, you think you are using less runway, but the OPT will also manage to reset your ATM to a higher number, say 45, say 50 degrees Celsius. And your V1, it's going to be a short number, but it's going to be reached at almost the same point of the runway. And your stopping distance will be roughly the same. So you're going to use the runway, all the runway, either way, because you're going to reset the engine thrust for that. So understanding what's behind the numbers that's been given to you by the OPT maybe makes your decision easier to accept, to use the lower flap setting, because there's no difference there. If you go for a higher flap setting, the ATM will be different and your stopping margin will be exactly the same.
Yeah, that's funny because that's exactly what I see here. People just have a rough idea of what they are doing and what are the consequences of changing the settings or interfering on the settings. Changing the SOPs. Just because they don't feel comfortable. And when it comes to this life, and I think all the work that you do, and we probably going to start doing together at some point, is just to help people to being more comfortable, right? By acknowledging more, by having more knowledge about performance, because this comfort zone is what makes the difference on a takeoff. Here, there is a little bit of difference from what you see maybe in Brazil, because in the Middle East, of course, we work at very high temperatures, right? And we have very long runways most of the time, like 4,000 meters long runways. So actually, the runway length is not quite a factor most of the times here. but the factor is the temperature, right? So normally, and we're going to talk about that, but in more details. But normally here, when you run the performance out of one of these airports in the Middle East, you always do improved climb. The OPT is always giving you improved climb, right? Because it's a very long runway, and you have a greater V2 in order to climb faster or to allow more payload into the aircraft. But this also gives you high speeds, right? So you're using a 4,000 meters long runway in a 48 degrees environment, right? And your view one is going to be something like 163, 164, right? The view one. Okay. Many people I see, when they see that, I say, okay, the speeds are high. I don't like that. I'm not comfortable with high speeds, right? Why? Well, they don't know exactly why. They say, well, I'm not comfortable with high speeds because in case of rejection, the speeds are high and the brakes are going to be hot. And then I want to drop these speeds because if I reject, the effect on the braking is going to be less. And so I think it's better for me. So okay, hold on there. That's not the only point you have to take into consideration, right? The rejection is just one part of the takeoff assessment, right? They don't understand that by doing the way they drop their speed is by going full thrust, right? Because you're assuming some temperature, and they go full thrust to drop their speeds, right? All right, very good. But how about if you have a V1 cut, right? And you're losing like 10, 12, 15 knots on the V1, right? And then you're losing speed that is actually everything that you want in case of V1 cut. You want more speed. And you want less thrust on the good engine, right? To help you with the yawing, right? At the same time, working in a high temperature environment, you want to lower the engine wearing. And everything that you're doing is just using the engine to a higher thrust, so close to its limits, causing a higher engine wearing that might cause the rejection that you're trying to avoid. You know what I'm saying?
Exactly.
So it's it is. I mean, I understand, but it's very clearly that it's a lack of a concept, lack of knowledge, that they haven't had the opportunity to go deeper into what performance is, what you have to consider for takeoff, right? I don't know if you see that as well.
Yeah, but with a different approach. Most of the pilots who talk to me about high V1 speeds, their main concern is the fuse plug melt zone. In case of an RTO, the fuse plugs are going to melt and I won't be able to taxi. And I normally ask them, all right, but
yeah, that's pretty much
what's the problem? Because
this is what they do.
Yeah, that's pretty much what's supposed to happen. Going into fuse plug melt zone is what's supposed to happen. The brake energy is going to be dissipated in some way. This way, it's going to be probably into the tire. It's going to be a high pressure. The fuse will melt and protect from explosion. But say you, instead of using a V1 of 160 knots, you're going to be setting for 145. What's the difference? Will you be able to depart again after a rejection at 145? No, you won't. You'll be heading to the gate at least, if not stopping on the runway because it is the brakes are too hot anyway. So honestly, this is more like we're not used to do that. So this change in using OPT and having improved climb almost all the time, it's like a shock of culture. It's not a matter of, okay, it's not good to do that. No, it's not that it's not good. It's just because I have never done it before. So, and I'm uncomfortable doing it now. It's just like this. It's not that it's a real major issue in any way.
Yeah, but how you think people can make themselves comfortable with performance? What is the best way to do it?
Knowledge. It's just studying the issue.
I totally agree.
If you study the issue, you'll see that this is what is supposed to happen. honestly, I have much more concern with short turnarounds. This is of a much larger concern to me than a high-speed departure. Because if you think about high speeds, you're normally talking about high payloads, high density of passengers on board. It's likely you had at least 1 hour, 55 minutes on the ground to cool down the brakes from the previous landing. And my biggest concern is not this kind of operation. My biggest concern is the kind of operation that you have just 25 minutes turnaround and you have landed on high elevation airport with maximum braking, and it's gonna depart kind of heavy again, and you're gonna repeat that for 4 or 5 times in 35-40 minutes period of flight. There is not enough time to cool down the brakes on this sector. So this is my main concern, not the high density that you.
I totally agree.
Yeah. I have the biggest concern.
I totally agree. I think
in this kind of operation, not having the brakes to reject in a low speed RTO. Low speed being 130, 135 knots.
Yeah, I totally agree. I think brake cooling schedule is not actually a big concern of most of the pilots. On at least on the 737, because it's not very critical, but people don't know exactly how to calculate. I don't know if the OPT for you guys there is updated, because we recently, probably 6 months ago or so, it's less than 1 year ago for sure. Our OPT now incorporates the brake cooling schedule.
Yeah.
We do have we do have all the calculations and all the recommended time on the ground or in flight for the brake cooling, and that's very, very helpful, because I see now people now trying at least to understand and having a look on the cooling time and taking that into consideration. I think that was a big improvement from Boeing to incorporate that into the OPT.
Yes, it was, but it's still missing for brake cooling for an eventual RTO. This is still missing on the OPT. For the MAX, it was always available from the beginning, the landing brake cooling, but the takeoff brake cooling in case of an RTO is not available yet. I know that our company has asked for Boeing to do it. I know that many other companies have asked them well. But I have no idea when Boeing is gonna release this kind of issue, this kind of feature on the OPT.
Oh, okay. Talking about RTO, and as we're talking about knowledge, right? About the importance of performance knowledge, right? Overall, as you wrote on your book, and I read it, and this other day I was reading an article about RTO as well. We know that only about 2% of the RTOs they happen at high speed, right? Something like that.
Yeah.
Right?
Above 120 knots.
Yeah. So from these 2%, more than 50%, they happen after V1, right? Yeah. So it's not. I'm not talking about if it's necessary or not. I'm talking about people they start the RTO in a time that you don't have runway available, right? So
shocking.
It's something that it's shocking. Although we study that our entire lives, you see experienced pilots still doing that. I'm not criticizing them. This is just a fact. Numbers, numbers they cannot lie, So for some reason, people are still putting their senses in front of knowledge, right? In front of what they've learned so far, and rejecting the takeoff after V1, which is, like you said, quite shocking. And there is an article from this article. I want to read a short, a brief piece of what I read, because it's very interesting. It's saying that the Flight Safety Foundation has has done a study of takeoff excursion accidents, right? And they found that the most common risk factor was an RTO initiated at a speed greater than V1. That's what we're talking about. And the Flight Safety Foundation reported on the study saying that many high-speed RTOs resulted from pilots' perceptions that their aircraft may have suffered a catastrophic failure that would not allow safe flight. The perception often were erroneous, indicating that many pilots may be predisposed to respond by stopping rather than continuing. The repeated fear that the airplane might not safely fly, giving some disconcerting event occurring after the V1, indicates a possible deficit in pilots' understanding of airplane performance and in their appreciation for the low probability of circumstances that would truly prevent safe flight. So, Flight Safety Foundation, right? They've made a very interesting study, and there is, the finding is that probably pilots are not completely aware of performance. They are missing performance basic knowledge. That's really interesting, right?
Yeah, and I will put the startle effect as a summary of everything you said, but there's one thing that always puzzled me in a way, especially was when I was a first officer yet. Sometimes I saw pilots after V1 leaving their hands on the throttles and just taking the hands off the throttles when gear up was necessary or something like that, either if they were pilot flying or if they were pilot monitoring. And one thing that I always taught my students was, when the V1 call is made, you will not try to stop this airplane. It will fly. So why leave your hands on the throttle? There's no reason for that. So the standard procedure is take your hand off the throttle, put it on the yoke, put it in your lap. I don't care, but take it off the throttles. Because if you, by any chance, have a engine failure, a fire warning, or whatever reason, it might make you startle, that startle effect, or puzzle what's happening. Your first action, even if you want to reject, it's going to be take your hands from your lap or from the yoke to the throttle, and that give you time to think twice. Oh, no, not to do that. Back, let's go fly in this airplane. If your hands are already there, that's it. You have already rejected beyond V1. So take your hands off the throttle. There's nothing to do there. Put your hand on your lap, put your hand on the throttle, on the yoke, and fly the airplane. That's one thing. And the other thing is what you talk about, having the knowledge of performance. Well, it is very rare to have an engine just shut down during takeoff. If the engine will shut down, it will shut down for a reason. And this reason is not always soft. It is like a bird strike. It is like a propeller that went off for any given reason, for an FOD, and that generates a very loud bang. It's associated with the yaw. So it's not like in the simulator that the engine just flamed out. It's something that really makes you scared for a couple of seconds. And so I understand this kind of will to stop. It's not going to fly. But trust me, it will.
Yeah. Well, that's a good word, because that's normally what I say, Listen, I understand your concerns, your fears, and your doubts, but the industry in general, many people, the entire industry has put so much effort into what we have nowadays, into like building up the OPT. So it's quite obvious that you can trust in what you have in front of you, the tools you use for your performance calculation, you know, like, so this trust, it has to come at some point. Otherwise, you know, if you don't trust on the OPT, for example, then you are in a very, very dark situation. Because listen, if you don't trust on the limits of the OPT, then you're building up your own SOPs, right? So, and this is like it's better that you start going deeper into understanding performance. So maybe you can trust better, you know, on the tools you have.
You know, this matter of trust has a situation that I always find funny, to say the least. Some flight crews, they try to cheat the OPT in a way, like say the aircraft has a ton or 2 tons more than its real weight. So we have some fat to burn. This is an expression in Portuguese. I have no idea if this similar expression in English, but this extra margin generated, it's to find out a assumed temperature that is fit to your current weight. Okay, and you're trying to cheat the airplane, saying that is 2 tons heavier, and you want this extra margin on assumed temperature method. But I ask, well, suppose you're taking off from a very short runway, like Congonhas, you know pretty well this runway, for a very long flight. So you're extremely heavy. You're flat 25, your bleeds off on a 737. The highest performance you can get, and that's exactly what you need to carry the weight you are at this very moment. I ask, do you, captain, or do you, first officer, do you trust the numbers? No, I don't. Okay, then do you ask 2 tons to be left on the ground, either cargo or passengers to leave the airplane? No, I don't. So when you are really on the maximum takeoff weight of the aircraft on that particular runway, you don't do anything. But when you're just using assumed temperature method, that is a fairly safe method, have some margins on that, built it on that, then you wanted to cheat the airplane. So I don't get it. What's your logic behind everything? I don't get it.
Yeah, that's true. Brenner, we're here chatting, and it's so interesting. We forgot to, you know, whoever is with us here on this live, if you have any question, please, you know, write it down. We're gonna read it, and if we miss it, Caio is gonna remind us that you guys have a question. So please send it to us. Yeah.
I have some here on my phone. I'm reading here. How about using intersections for takeoff? What do you guys think about it? Would you like to start?
Yeah. Well, yeah. That's it's not an easy question to answer, you know, because of course that you know, if you think about the runway available, you always would like to have the, you know, the longest runway available for you, right? So if you are like scared, you know, if you're always fearing that something's going to happen, right? Then, you know, at the first thought, you could say, I will never take an intersection, right? But by using the OPT, right, by using these tools, when we use the intersection, we are actually calculating the performance based on the runway available for you, right? So on my thought, I think it's completely normal to use intersections, because as long as you set the intersection on the OPT, because I don't have this feeling that it's unsafe, or it would be safer to go with the full length. What do you think, Brenner?
I'm all for it. Use the intersection whenever possible, because once again, if you have, say, random numbers again, you have 2,500 meters of runway available from the threshold. Your OPT is going to set, okay, you're going to take off flaps 1 and you're going to use 55 degrees of ATM. If there is a runway intersection for departure, use it. But remember to tell the OPT. That's the only advice I'll make you, okay? Remember to tell the OPT you're taking off from that particular intersection. And it's going to be now 2,100 meters available. All right. Your ATM is going to fall from 55 to 37. And you're, again, using all the runway available. So it doesn't matter if you're taking off from the threshold or from the runway intersection. Go for it. But remember to tell the OPT that the runway is getting shorter. Just that. We had some major issues in the past, and unfortunately, they're still happening nowadays. One A340 once departing from Miami. Okay, one A340 departing from Miami. They departed from a runway intersection, but telling the OPT they were departing from the runway threshold. So this kind of scenario, it's very, very dangerous. Another kind of scenario that is very dangerous is to put a wrong number in the OPT. For example, there was another incident. I can't remember the airplane, if there was a 777 on an A340 again. But the takeoff weight, the actual takeoff weight was 323 tons. And the input was mistaken by 232, so 90 tons difference. It was a major incident again on departure. So garbage in, garbage out. If you put some numbers wrong on the OPT, you'll get the wrong numbers for takeoff as well. So that's the major issue. Not departing from a runway intersection, but not telling the OPT you're departing from that intersection.
Yeah, and I think rushing into deciding that it's a big concern. So if you make that decision on the ground, on the stand, right? Discussing that, making sure that you have the intersection, and when you go there, when you were close to takeoff and you confirm, it's fine, because as you said, you're going to use, you're going to have a lower assumed thrust when you shorten the runway. So that means that the engine is producing more thrust. So your acceleration is going to be faster, right? So and now the calculations are done for you in order to have enough room for that takeoff or for a stop if you need to reject the view one. Let's say view one. I know it's not the view one exactly.
Okay.
It's view one. Caio, I think Caio has a question.
No, I just have something to add here. I think some people actually feel anxious about using runway interceptions because they think they need to redo stuff and actually change stuff in FMS systems and all that stuff. So one thing that Felix told in one of our master classes was to get stuff pre-calculated way ahead, fly in front of the airplane. So let's say we are assuming we're gonna take off full length. Okay, that's fine. But let's, just in case, calculate what is the most restrictive intersection we can accept. So we can facilitate for controllers and for air traffic management sense. So let's calculate that and say, okay, we can take interception Alpha, Bravo, and Charlie. So let have that ready and just change if needed. But yeah, it's not a big of a deal if the OPT says you can do that. Probably you can. So just make sure you have the right numbers and go for it.
Yeah, it's perfect point. And Conrado also made a point. Get this decision made on the gate and get time to run the numbers. If you're taxiing already to the threshold and something changed, don't rush into the intersection. Stop the airplane, make the calculations, brief the departure again, and then accept the departure from that runway. It's just a matter of not rushing. It's not a matter of not accepting.
Yeah, and obviously you're using an intersection because it cuts you some time, right? Maybe it's worth it for you in terms of taxiing, right? So but the thing is, like Brenner said, have that decision made on the gate and have the numbers on the FMC already done on the gate. Because if you have to stop at the holding point and put on the numbers again, then you're going to lose a lot of time, right? You have a lot of procedures to do, and then it's not worth it to do. But maybe in that case, unless the ATC tells you no, you have to take that intersection, then okay, it's a different story. But if you decide to go for the intersection, you have numbers for full length, and you have to put it on again in the box, then maybe it's just worth it to go full length, right? Because you already have the numbers, and you're not going to waste more time. In that case, it's not that you're rushing; it's that it's just facilitating your own performance by making it simple. So one of these things about performance and intersections, like Brenner was giving examples about the 340, the 777. Sometimes we rush, and when we rush, we make it complicated. So the most important is make it simple, and when you make it simple and safe, then normally it works. But what is interesting, there is another data that's interesting as well, that from these high-speed RTOs that we mentioned before, like the 2% of the total RTOs that happen at high speeds, only 20% more or less of those RTOs, they happen because of the engine malfunction, right?
Yeah, engine-related
which is quite interesting. Engine related, well, yeah, any kind of engine engine indication, not even a malfunction, right, or different indication. So engine related. And when we brief about our takeoff and about our RTOs, we always follow the same thing, those 4 factors at high speed that we would reject, right?
Yeah, I don't like those.
Fire. Yeah, me neither. It's a bias. So it's fire, any kind of fire, engine failure, right? Predicted wind shear, or a situation that makes you unable and safe to fly, right? And this is so wide, it's such a gray area in my point of view, right? Because unable and safe to fly, and we saw on this Flight Safety Foundation study, and that's where things happen, undesired things happen, because what you think is unsafe is different from what I think is unsafe. That depends a lot on your experience, on your airmanship, on the day, because you might be super tired, you might haven't slept well, and your brain is not working at 100% yet, and that judgment of what is safe or unsafe, or that would make you unable to fly, it's such a wide area, and I think we as pilots, we have to think about this scenario, because on the sim, right, training, we are biased by an engine flameout, right? That's mostly what happens at V1, a V1 cut, engine flameout. Why? Because in terms of performance, that's the worst case scenario, right? Out of a suddenly you lose 50% of the thrust you have available. So in terms of performance, yes, it's the worst. But I would say if you perform well, if you do everything accordingly, everything's going to go well. You have the numbers, right? You control the aircraft, and everything's going to go well, right? But how about this feeling of, okay, is this safe or unsafe to fly? How we process that, Brenner?
Honestly, I don't have any situations that I consider unsafe to fly after 80 knots. And let me put in this way, on the book, what I mean is there is no checklist that I ever made. There is no situation I ever faced on a simulator that I consider that is not safe to fly after 80 knots. So I would move on until V1, VR, and continue to fly. With one single exception, that is ATC asking me to stop the departure. We had an event here in Brazil a couple of months ago. But we had many others in the United States, and you can see on VAS Aviation channel. It's a great channel. Recommend you follow it. For example, pilots taking off from crossing runways at the same moment. They understand. One of the pilots was instructed to take off, the other was instructed to hold, and both started rolling. So if the tower in a given moment noticed what was going on and asked me to stop, I would stop, because I don't know what's happening. I just understand that someone is telling me to stop. I don't know if there's an aircraft about to cross the runway. I don't know if there is an issue with an aircraft flying, like Congonhas, for example, helicopters crossing the other end of the runway. I don't know what's happening on that moment. I just know someone is asking me to stop, and I will stop. That's the only unsafe to fly issue it's on my mind at this point. You can tell me of other issues that maybe you will tell me something I have never thought about, and it will go into my database. Oh, okay, if that happened, I will stop. But at this very moment, just this one. And when we talk about that standard briefing, like a predictive wind shear, so it's an issue that I have flown simulator for almost 15 times in recurrent, now flying for 15 years on the same airline. And I have never seen a pilot reject a takeoff after 80 knots on a wind shear. And that's for a simple reason. In the case of the 737, I don't know, I'm not speaking of other airplanes. The 737, the call out for wind shear, it's inhibit every 100 knots. So if you got a wind shear at, say, 120, everyone sees the speed indicator stops growing. Sometimes you even lose some speed. And the first reaction of every pilot in this 15 years was always the same. Like, firewall, wait for closing the end of the runway and try to hold tight and get lift off. Well, but haven't you briefed you will reject in case of a wind shear after 80 knots and before V1? Well, I did. But why haven't you stopped? Because there was no wind shear call. But will never be after 100 knots and the 737. Might be different other airplanes.
You have 20 knots, which means probably 3 seconds or so, right? Where you may get the predictive wind shear warning.
So the predictive wind shear warning is just from 80 to 100, and after that, it's on you. So putting that on my briefing, I always tell the pilot sitting right beside me, if you perceive a wind shear without any call, without any automatic call from the airplane, yell wind shear. So I'm gonna take the appropriate action, either go or stop. But we need to yell this situation. And that's another call. For example, fire. We always talk about engine fire, but we never talk about other kinds of fire. So I always take in my briefing, I will stop for any kind of fire, either a cabin fire, the flight attendants ringing the bell to me, cargo fire, APU fire, engine fire. So any kind of fire and engine failure. These are the two that I'm going to stop. The others are, well, let's see.
Yeah, I cannot tell you any other situation where I would stop, I would reject, because I totally agree with you, 100%. And this is, but you see by in studies and by numbers that this is a big concern. This is a critical area. And I think by studying and by having more information, or by having discussions like this discussion we are having today, with other pilots, right? Actually sharing thoughts and asking others, why would you reject for? What would you reject for? So would you reject for, airspeed unreliable? Would you, because we have to put this out, because we're not superheroes. Some pilots, they think they are, but we're not superheroes. We are limited, and we learn from others' experience. We learn from talking to a guy like you, who is a master on performance. We learn from talking with someone with a lot of experience, that has flown for like 40 years, and you see these guys, it's, these guys, he's flying for 35, 40 years, he doesn't follow SOPs and blah, blah, blah. But, this guy's so much experience, and he has so much to, teach us, in terms of what he has seen along these years, so I really, really recommend everyone to, take this very serious. Performance is something that make you safe, that can save your life, and that, knowing performance more in deep will help you a lot into your decision-making process, especially during this moment, during takeoff, which is critical.
I have other questions here. Just let me go by the chat here 1 second. Will this live stream be available later to watch? If you're here yet, yes, it will.
Yes.
Good topic for this discussions. What about those that use higher flap setting to avoid high V1 because they don't trust the tire speed limit? Well, I guess Conrado is out of maybe a problem with connection with Conrado.
Well, again, it's a matter of trust, right? A matter of trust. So the OPT is taking that in consideration, right? All those limits I've been taken in consideration by the OPT or whatever is the tool you're using, right? So that shouldn't be my concern, At least I completely trust on the OPT. So if the tire speed is the limit, you're gonna have a lower speed. You're gonna have a lower V1, right?
Yeah, when the tire speed is the limit, the issue is the VR, as you said. But
it's the VR, yeah.
I guess there are two things that you have to consider. When tire speed is the limit, your rotation technique must be very accurate. Rotating at a very slow rate, it's gonna make the tire go very well above the tire limit speed. So that's one issue you might have on your head during takeoff briefing. Rotate the airplane at the appropriate technique. And the other issue is, if the tire speed is exceeded, what's going to happen to the airplane? Well, all tires, when they are certificated, they have a one-time exceedance available on their project. We have on the 737 have in our, at least, 225 miles per hour tire speed limit. The bias and the radial one is 235. I don't have the numbers on my head right now. It is on my book though. I guess that 235 goes to one-time exceedance to 250 or 252. So it's quite a margin to be worried for one time. And if this speed exceedance happens in this one time, after landing, it will be checked on the flight operations quality assurance, and the airplane will be grounded to change that tire. So I wouldn't be worried for this situation, not at all. Just a special briefing taking care of rotation technique, 2 to 3 degrees per second.
That's a very good point. That's a really good point. Any other question?
Let me see here. They think tire may blow or disrupt hydraulics, even damage. Okay, Rodrigo Castanheira, thanks a lot. I think it is safe and okay to use intersections, looking at the big picture, no wind shear, etc. Let's do it. Totally agree. The same guy who asked first. Awesome. I am asking because some pilots don't like to use high V1 or want to use the full thrust just because they want. They do the same for the intersection. Yeah, that's what you told us. Some pilots tend to draw their own SOP. That's more often that we wanted.
And I believe this guy who is sending this question is probably an FO, and I feel for an FO in that moment, because I know it's kind of quite a tough situation where you know that the guy is not doing the best. I wouldn't say the guy's wrong, but he's not doing, the best. His decision is not the best, right? But it's quite tough for you as a right seat, as a first officer, to challenge that, And of course, at some moments, you just it's better to let it go. You can kind of smartly give the guy an input or something like that. But yeah, you wouldn't start like a discussion just because the guy wants to go full thrust from an intersection, right? So yeah, I feel for you, my friend. I really feel.
Yeah, getting the right seat is kind of an art to be there. You have to be something that you are not. But I would say this: whenever the left seat pilot's doing something that you don't agree, but is not a safety issue. For example, I want because I want to take off on a higher flap setting. I want because I want to take off on a full thrust. Try to show this pilot the reality. Try to argue with this pilot the reality on the gate while still have time, or it is still comfortable to do so. If you lose that argument, that's all right. It's not a matter of safety. Yeah. The pilot's going to do something that is not a standard SOP, but is not a safety issue as well. But once the pilot tries to do something that is not that is a safety issue, say for instance he wants to depart from a runway intersection without using the runway intersection or the OPT. So this is a major
without having the numbers for that intersection. Yes,
exactly. So this is a major thing. So now it's time for you to step up and say, no, we're not going to do that. Other way, you're just find another first officer because I'm leaving the airplane. This is not acceptable. Then you have to step up really.
Yeah, and I would say that the best thing to do when it's not a safety issue, like you said, is just do exactly what you're doing. You are trying to become a better pilot by following us here, asking questions. And then you learn from the others. That's probably the easiest way to learn. You learn from others' experience. And when, especially on the right seat, it's very easy to learn from others. You learn from captains. You learn what to do, and probably even easier to learn what not to do. So sometimes you don't need to question the captain about his decisions, but you question yourself later, and then you go home and you think, okay, this guy decided to do this, but is this the best one? What should I done different, and then you come here in this live and you ask Brenner, a master of performance, and then you go to the books, and then you find yourself the best solutions, And another thing is that when, like Brenner said, when the captain makes a decision like that doesn't affect safety, but it does affect the flight, right? There is a consequence of whatever, going full thrust or flaps 25 or whatever. If you know the consequences, if you know what can happen, it's okay. It's enough. Because if you are comfortable with that, when you know, you will be comfortable with anything. Like Brenner in the beginning of our live here, I think he said, okay, someone said that he wants to go with flaps 5, not flap 1, right? He wants to have a greater flap setting because he's uncomfortable. And Brenner said, okay, I'm happy. I'm okay. When you have the knowledge, you make yourself comfortable with any condition. And that's the most important, So you know what's the consequence, and you know what you can expect from that, as long as it's safe. So yeah, our fellow there, I know it's tough, but man, keep working and keep learning, and keep sending questions, because I love that. I love that.
We have a few comments.
Any more questions we have?
We have a few comments on Farol de Pouso's YouTube channel. William Weber said, some performance softwares actually have a graphic or a number showing the actual stopping distance margin if rejecting at V1. I hear quite a few pilots with a mindset more towards to reject a takeoff at V1 than actually go flying due to a stop margin that you could maybe stop before the end of the runway. I'm not sure what are the benefits of having this info instead of a simple stop-go decision.
Yeah,
Brenner.
Please.
this kind of mindset, I think that is very important. William, you're absolutely right to have a mindset, but differently from the pilots you are flying with, my mindset after 80 knots is always go, just because. And the situations that are making me stop are so rare to happen. That is engine failure and fire of any kind. These two situations are so rare that you have to have your mindset more prepared to go than to stop. Because if anything happened, like a master caution saying the door has opened, or at least a master caution warning for a door open, sometimes the door haven't even moved an inch, but this thing will get you startled, and with your mindset to stop, you will stop for the wrong reason. So you have 1 second to think about stopping. Use this 1 second. Use this 1 second to not to get the decision, but to get the action to stop. Something happened. This is what I briefed is one of the reasons for me to stop. If the answer is no, and it will probably be no, go. My mindset, at least, I don't know if Conrado agrees with me or not, is more go than stop. But having the information of what the margin is to stop, I think that is always a good idea. To see, well, I'm going to stop here. I will have no margin, no extra margin. I'm going to lift off here. I'm going to reach 35 foot, the 35 feet point. It's going to be here. So, yeah, I think the information is nice, but know what to do with it.
Yeah.
I agree.
Please,
sorry,
please.
Kyle. No, yeah, I just to complement. I totally agree with you again, Brenner. I'm also out to go. My decision is, always, my mindset is always go, but I understand what Whedon, I think Whedon, right? Yeah. What he's saying, that having those arrows, having those, that visual picture, right? Again, if you understand about performance, you wouldn't be concerned about it. Actually, I like it. Myself, so now I'm saying I understand about performance, right? But I do like having those errors. I like to see, what the OPT is calculating and the result of the calculation. I really like to see. But yeah, I understand what he's saying, because I see that sometimes, actually, I would say quite often, when some pilots, they see the errors touching the edge of the runway, or sometimes going over the runway, crossing the threshold, which is completely fine, but they don't know exactly what that means. They say, no, I'm not happy with that, so I'm going to do something. I'm going to increase the flap setting, or I'm going to go full thrust, or whatever. I'm going to do something because I don't want this arrow to be touching the edge of the opposite threshold, Again, it's about information, it's about knowledge, it's about trusting on something that you only can trust if you acquire knowledge. That's it.
Yeah, and I think it's interesting because the OPT it has the ability to calculate the optimum setting for your performance, but you can also override that and use your own settings and choose the flap setting and choose the thrust configuration that you are using. So you might actually lose the conscience of what is happening and what possible gains you might be losing from assumed temperature and balanced V1 and improved climb. So it's actually interesting to think, okay, the business, the market, the industry, yes. The industry uses these methods because they have some kind of gain, some financial gain for the company, or some durability gain for the engines and everything. So by choosing a higher flap setting or a higher thrust, you might be losing these benefits. So it's actually quite interesting to have the numbers.
Not only for savings, but for you as a pilot as well, because the OPT, by having the OPT preset for improved climb, right? We're talking about Boeings, right? I only know about Boeings. I haven't flown anything else. But talking about the OPT, by having improved climb, what happens? Man, if I have a V1 cut, which we already said is the worst case scenario in terms of performance, right? I will have higher speeds, right? I have a higher V2, and I have less thrust in the good engine, which helps me with the yawing, which helps me with the climb, right? So it's a win-win for us as pilots, right? So of course it's a you're doing engine savings, savings for whatever the industry, but it's my takeoff. I'm there. I'm the one responsible. I want to save the engine, right? I want to save the engine by reducing the engine wearing. I want to have greater speeds if I have runway available, because that will help me out in case I have a V1 cut, because my margin from stall is going to be greater. I have more margin to control the aircraft, and I have less yawing, and I still have thrust available if I need at some point. So I really don't see any reason to don't use ATM when it's available, right? By the way, Brenner, I know you're gonna make a comment, but just Caio, he's not a pilot. Can you believe he's not a pilot? Caio he has 1 flight hour logged on his logbook, only one. Can you believe, man? At this stage of his life, he's still dreaming about being a pilot. Can you believe that he has this knowledge? I would be such an amazing pilot if I was like him when I was his age.
Oh, stop it, you.
No, Caio, I had no clue that you were not a pilot. You were talking to us like you were one. And if you were one, I would tell you would be a very good pilot. Or I would like to fly with you. And talking about V1 cut again, once I was asked during a class, what if you were departing from a very long runway? Say Al Maktoum, am I right? The one there in Abu Dhabi.
Yeah, Al Maktoum. Al Maktoum is the new airport of Dubai.
Yeah, it's. I landed there once. I believe it's a 5,000 meter long runway.
Yes.
Yeah.
I think 4,800 meters. Like that.
Close to that. Oh, say here in Brazil, Galeão, 4,000. You're departing from this runway, you're only using like 2,000 to depart with ATM. And once you are rotating, something happened. Or once you are just after V1, something happened to your engine. Is it worth rejecting above V1? So, never worth unless the airplane is not flying. I'll give you one example. The MD-80, there was an MD-80 in the United States 3 months ago, I guess. It was being used for executive flight. It was FAR Part 91, I guess. Was taken off, and the controls were with the lock. I don't know, how do you say that in English now?
It's control lock.
Control lock. Okay, the controls were with control lock on the tail. So the pilot could not rotate the airplane. That you have no choice. You have to either go to the end of the runway at a slower speed, trying to stop, or either with the ultra high speed with engines at full thrust. That's the only choice you have.
And that's a very obvious condition of unable to fly. It's completely unable to fly, right?
You're unable to push the airplane into the air. But despite this situation, please go. And when I say please go, I have a video. Well, the airline is not operating anymore, so I can tell you the name of the airline. Is U.S. Airways A320 departing Charlotte, if I'm not mistaken. The cameras off the airport caught the scene. The pilot was just lifting the ground. After rotate, getting to V2, he decided to reject. Once the thrust lever were pulled back to idle, the airplane went back to the ground with, in a very aggressive way. It tail striked. It porpoised on the ground, so it hit the ground, flew over again, tail strike for the second time. Then it smashed the nose gear into the ground. The nose gear collapsed, and he went off the runway. So it doesn't matter if the runway is long. When you pass V1, you are committed to go. So go. The runway has 5,000 meters in front of me. Go. Get up. Analyze what's happening to you. Do any appropriate checklist you might think it's needed to do. Think about, plan your new landing, and come back. You'll have all the 5,000 meters available for you if you're doing that. If you're not doing that, you're going to have like 2,000 meters available for you in front of you. And in a situation that you're not prepared, you're not trained, and you'll probably crash this airplane.
That video is quite interesting. I've seen that, and it's probably the first case of bounced takeoff.
Yeah.
There is right? It's a bounced takeoff. Yeah. Unfortunately, right? Because there was a crash, but yeah. Guys, we've been talking for more than 1 hour so far. It's been great. I didn't feel it. I just had a look at the time. It's 1 hour and 10 minutes. Do we have any additional more questions, Brenner and Caio?
Just some comments, no questions here.
Yeah,
Caio, from our side, from Farol de Pouso.
We had one from João Miguel. Why not run numbers at the gate for the most restrictive intersection, and having that you can use any other portion of the runway for takeoff?
You could do that.
Yeah, it's pretty much what we've been talking.
You could that just have in mind that sometimes running the numbers for the worst case scenario would put you in a situation that you are not allowed for ATM, for example, or flight temperature, whatever you call it in the airplane you're flying. And if you are to take off from the threshold, so you're losing a great opportunity here. I guess, it's just my opinion, run the numbers not for the worst case scenario, but for the most realistic scenario. For example, whoever is watching us who knows Porto Alegre, if you're running at a takeoff analysis to depart from runway 29 in Porto Alegre, the taxiway does not leave you at the threshold. It leaves you like 300 or 400 meters beyond the threshold. So that's a good opportunity for actually departing from this point, because you're likely to be able to depart and from this point of the runway. But if you are departing from Galeão runway 10, I'm talking about my experience here in Brazil. I know if guys are watching from other sides of the world, will have their own pictures in mind. But if you're heading to runway 10 in Galeão, you're going to hit the threshold during taxi. You're not going far to take off. So you don't have a point in doing a different analysis than from the threshold. So do whatever is the most realistic scenario and not the worst case scenario.
And I would add, Brenner, something else there. That's my point of view, and that's why we're paid, right, to make our own decisions as well. On top of the SOPs, right? So put on our experience, our airmanship, and try to make always good choices, good decisions. I'm always up for ATM, always. I don't know. I know I operate here in the Middle East under very high temperatures in the summer, right? But I'm always up for ATM. So answering the question from our fellow that I forgot the name, sorry. Yes, I think, yes, that would be a good technique, right? I also go with Brenner that it would make more sense to, expect the most probable intersection. That makes sense, but you may lose some reduced thrust, so you may have to go full thrust, right? If you go for the most conservative intersection, and then you know what? I always do this evaluation because I really care about the engine wearing, because something might happen on that takeoff, on my takeoff. That's how I think. And if I can use ATM, if I can reduce the engine wearing, I'm always up for it, because that might avoid some issue with the engine, because ultimately the engine works with rotation and temperature, right? That's how an engine works. So if you reduce the rotation, if you reduce the temperature, even if it's just a little bit, you may be avoiding some damage on the engine, right? So you're preserving your own takeoff, not the company. I'm not talking about cost. I'm talking about your own takeoff. I'm always up to. So I do this evaluation, right? So maybe if I take the shortest intersection, that will give me full thrust, and then I have two other intersections. Maybe if I take one like a little bit behind that one, and that will give me a little bit of ATM. So I was always up for it. So I do this also this secondary evaluation on my judgment. Any more questions, Kyle?
No, I don't think so.
Brenner, final thoughts?
No, just thanks a lot for this invitation. I thought that was a very nice chat. I'm about to launch the first videos in my channel in English. I have 25 videos so far, and I intend to re-record those videos, but in English now. Let's say if I can release the first one by the end of the month, and then moving on from this point. And this was like the introduction to English speaking in this channel. But don't worry, I'll keep posting in Portuguese as well.
Oh, that's great. I'm personally, I'm really looking forward to your videos in English, because I would not need to translate your videos to my students here, because this is it's quite embarrassing at sometimes, during the briefing, I show videos, for some of these guys, and I have to stop every 15 seconds to translate, and they are so into it. They say, hey, when this guy's gonna release videos in English, So, and now, making a jabba, advertising, for my friend here. So for whoever is not aware of this book, right, from Captain Thiago Brenner, Aircraft Performance, Weight and Balance, right? It's on Amazon, and third edition, English version. It's amazing. I have my own, and I'm receiving briefly, I think next month, 20 editions of this book. And whoever is here in the Middle East, you can get in contact with me. So we are offering this book for lower price than Amazon, right? Competition here. Yeah. So, but I'm doing that because I truly believe that this book is a Bible, and whoever is interested on learning a little bit more, obviously I haven't read the entire book yet, but I use as a reference for something that I want to double check, or if I want to learn something in deep. So I just go for the topic and I use it. So good luck, Brenner, with your English videos. You can count on us at any time. I think this is a great partnership, Farol de Pouso and Aircraft Performance. Best of luck, and we keep in touch. And maybe if you guys enjoyed this video, we can do it again. I would really appreciate if you guys send us some topics, like if you really enjoyed, just make a comment on YouTube, whatever, Instagram, and
hit the like
tell us
button.
what you'd like to. Yeah. Yes. For sure. Hit the like and tell us what you'd like to. What topic you'd like to hear from us here, and probably in another video like this. Right, guys. Thank you very much. Was a pleasure.
Thank you, guys.
I hope we do it again very soon.
Conrado, can't thank you enough for everything you're doing for me right there in the Middle East. Thanks a lot. And thank you, Farol de Pouso. We're going to repeat this for sure.
For sure. Thank you, Caio.
Bye-bye, guys.
Thank you, guys. Okay, so let me see. I think I might have messed something in here. Where's my cam? Here it is. Or it's not. No, it's not. Okay, whatever. I'll finish from this screen. Thank you, everybody who's remained here until the very end. The video will be available on our YouTube and on our other platforms as well. So you can watch it later, you can send it to your friends. Don't forget to hit the like button, subscribe to the channel, and all that stuff that we know happens in YouTube. And thank you so much. See you next time, and bye-bye.
Ciao.